Morning to everyone present here. I'm Sangeeta Lakshmi, working as Assistant Professor in R.M.K College of Engineering and Technology. Today we are going to see the Unit 5, that is Implementation Strategies and Testing in VLSI Design. First of all, we have to know some information about the FPGA. What is FPGA? FPGA means Field Programmable Gate Array. We have studied this FPGA in Unit 1 and 2. In this unit, we are going to specially concentrate on the building blocks of different kinds of FPGA provided by different vendors. So we have, first of all, we have two types of FPGA. One is reprogrammable FPGA, another one is one-time programmable FPGA. In reprogrammable FPGA, it is based on the memory, that is, it uses the SRAM memory with some basic logic cells. Whereas in one-time programmable FPGA, the basic logic cell is based on the multiplexer. And also it uses the anti-fuse because it is one-time programmable. So it uses the anti-fuse based programming technology. See, whoever providing this one-time programmable FPGA or Apple as well as the Quick Logic. These two vendors or manufacturers providing this one-time programmable FPGA. That means we can buy the FPGA kit and we can program this FPGA in our field, but it is only one time. Okay, so again, which is not able to reconfigure that. But the first one is reprogrammable FPGA. In this, what happened? This kind of FPGA can be reprogrammed in any number of times. It is not limited. So infinite number of times we can reprogram it. So whoever is providing this kind of FPGA are Xilinx, Lattice, Atmel, Altra. These all the vendors or manufacturers um, developing the reprogrammable FPGA. See, out of these, all the vendors, Xilinx as well as Altera, both are occupying the 60% of the share in the FPGA market. So, out of 100%, 60% of the market is occupied by Xilinx as well as Altera. First topic in Unit 3, we are going to discuss about programming technologies for FPGAs. That is how the FPGA is reconfigurable by using different programming technology. So, the basic element which is present in the FPGA are, the first one is programmable logic cell, the second one is programmable interconnect, and third one is IO block. So, in this, the programmable logic cell within an FPGA are configured by using different programming technologies. So, what are all the technology we are using here is, the first one is anti-fuse, which is used in Actel FPGA, and second programmable technology is static RAM, which is used in Xilinx FPGA, and third one is EEPROM as well as EEPROM in Altra CPLD, that is complex programmable logic devices. They are using the EEPROM as well as EEPROM technology. And the programmable interconnect, usually this interconnect is nothing but the wire. It is programmable, is used to connect between any two logic cells. So the programmable interconnects are always used to make the connection between two programmable logic cells. So we have different kinds of interconnecting architecture also. That is, we are going to study in the fourth unit. But simply you have to know the intro of this routing architectures, that is segmented channel routing as well as LCA interconnect architecture. So these two are used in different FPGAs that we are going to see in the fourth unit. Next, we are going to see one by one how the anti-fuse is used to program your basic logic cells, static RAM, EEPROM and EEPROM we are going to see. First, anti-fuse technology. See, the anti-fuse is the opposite to regular fuse. Actually, in fuse, it is normally it is in the closed form. The switch is closed in the fuse. Whenever if you are applying the or programming the fuse, it will be not open. Okay, that is the concept of fuse. But anti-fuse is opposite to regular fuse. It is normally it is an open. The switch is normally open. Whenever if we are try to apply the large amount of current or programming the anti-fuse, it will close the switch. How it will close mean, for example, if you are taking the Pauli diffusion anti-fuse, it has three layers. This is your bottom layer, this is your bottom layer, and this is your top layer. In between that we have the ONU, that is dielectric. See here, this ONO dielectric act as an insulator, and top layer as well as the bottom layer act as a conductor. Okay, generally if you have the insulator means it will produce infinite resistance. So normally anti-fuse, it will provide the large amount of resistance in between the top layer as well as the bottom layer. Whenever if you want to program it, you have to apply the large amount of current. That current will melt this ONO, that is insulator. So due to that, what happens, top layer as well as the bottom layer, both will be connected together. Thereby permanently it will be touched together, which will produces the some resistance, low resistance. Initially it was infinite resistance, then it will be reduces to very small amount of resistance because of its programming. So anti-fuse separate the interconnect wires on FPGA, and programmer blows an anti-fuse to make a permanent connection. See, this process cannot be reversed. Once you program it, you cannot able to reverse it. That's why it is called one-time programmable. So this type of anti-fuse technology we are using in the Actel FPGAs. The next programming technology is static RAM cell. So in this, you can see here in all the place we have the stack, that is logic cell. This is logic cell. Here also we have the logic cell, and in all the four corners we have the logic cells. In between the logic cells we have the programmable interconnect. Okay, so in this we are using the SRAM technology. It is based on the SRAM technology. Here you can see this SRAM can be used to turn on this pass transistor. If we are keeping this SRAM to 1, this pass transistor will goes on, so that this vertical line as well as this horizontal line will be connected together. Right? So like this we can program this wires to make the connection between one logic cell to another logic cell. Here we can see another SRAM which can be used to control the any one input of the multiplexer. So the SRAM can be used to control this multiplexer, right? So what is the advantage of using the static RAM in this? See here, it is reprogrammability. When compared to anti-fuse technology, it is reprogrammable, and also it uses a standard CMOS technology. Thereby we can reduce the area, increase the speed, and reduce the power consumption with a smaller geometry. That is the advantage of using static RAM. And what is the disadvantages? It is volatile. That means whenever if you are switch on the power, the data will be lost. It won't store the data. It won't preserve the data. Okay, that is called volatile. So in order to preserve the data, we need external memory, but additional area will be required for this. So that is the drawback of static cell based programming technology. See here in the SRAM, what we have here is we have the SRAM can be constructed by using 6 transistors. It is called 60 SRAM. See, we have 6 transistors starting from M1, M2, M3, right? M4 as well as M5 and M6. See, this WL is nothing but the word line, whereas this DL is nothing but the vertical line, right? So in this, see here, whenever if you want to write the data, for example, if you are having the data VL equal to 1 means VL bar equal to 0. You are going to write the data which can be stored in your inside of this is nothing but the flip-flop. The whole network is flip-flop. So in flip-flop having the two states, one is the output Q, right? Another one is Q bar. So here only the data will be stored. So whenever if you want to write or read the data, you have to apply the WL equal to 1. So if you are applying 1, what happens? This transistor will goes on. Similarly, this transistor also goes on. So due to that, what happens? This 1 will be coming at this point. So the node 2 will store the data 1, which is nothing but the VDD. Right? VDD is nothing but logic 1. Similarly, here the 0 will be coming here. At this point, node 1 will store the logic 0, which is nothing but 0 volts. Okay. So, in this way, we can write the data in this. See here, whenever the 0 will be coming here at the node 1, this will be connected to M6 transistor, right? This will be connected to M6 transistor. Thereby this M6 transistor will goes on. Through this, the supply will be connected through this M6, and at this point, the Q will be maintained as 1. Similarly, in the node 2 having the logic 1 means that 1 will be connected to here. So this 1 will be connected to this M5 transistor as well as M1 transistor. So due to this one, the M1 transistor will goes on. If it is on, through this transistor, the ground will be connected here and the node 1 will be retain this 0 volts. So the static RAM cell uses the positive feedback to preserve the data at node Q as well as Q bar. So this is the way we can write the data. If you want to read the data means, similar way you have to apply the word line equal to 1. Whatever the data stored in Q and Q bar will be, you can see at the BL line as well as BL, right? So we can write and read the data from the Q and Q bar node. The next technology is EEPROM as well as EEPROM in complex programmable logic device. See, it is the non-volatile. Actually, how the programming is happening in this EEPROM as well as EEPROM is, see here, this is the symbol of EEPROM device. Okay. So, this two lines indicates that we have two gates. That is, this is nothing but the control gate. The second one is called as floating gate. So we have two gates. So it is called as floating gate mass transistors. Okay. So in this case, if you want to write the data, you have to apply the voltage which is greater than threshold voltage. So if you are applying the more and more voltage, what happens? You know the channel will be created right between source and drain. Okay. So the channel contains the minority carriers. You are applying more and more VGS, what happens? The charge carriers will be attracted. So it will be trapped into the floating gate. The gate 1 acts as the floating gate. So all the charge carriers will be trapped to the gate 1. Okay. So that means in this we have written the data state 1. Okay. So if you are applying more VGS voltage which is greater than VTN, the charge carriers will be trapped into the gate 1, which is nothing but the programming or writing the data of 1. Right? So suppose if you want to read the data, means you have to apply again the voltage between drain and source. Okay, drain and source we have to apply. See, all the charge carriers will be trapped into the gate. So even though if you are applying the voltage between drain and source, the current will not flow because there is no channel is present here in between source and drain. So the current will not flow. So what is the meaning of that is, if the current is not flowing here means, if the current is not flowing, it is zero means, we can say the gate, the floating gate contains the charge carriers. Thereby, we preserve the data of state 1. Okay. Suppose if you are applying the voltage between VDS and ground means, and if the current is flowing, if the current is flowing in the sense, if the current is not zero, that means the current is flowing from drain to source means there will be a channel. That means there is no charge carriers is present in the floating gate. Thereby we can say this, it is written that the state is zero. Right? So it is the non-volatile because it will preserve the data in the floating gate. It does not require any power to preserve the data. Okay, so that's why it is called non-volatile. See, the third diagram shows that the same concept, but here instead of electrical signal, we are giving the UV rays, ultraviolet rays, to write and read the operation of this floating gate transistor. Okay, so this kind of device is called as EEPROM. This device is called as EEPROM. So both are based on the floating gate type transistor. Okay. The advantages is it is non-volatile and it is area efficient. Okay. Disadvantages, it cannot be reprogrammed. Right? It cannot be reprogrammed like a SRAM cell in infinite number of times. Right? And it is limited time. We can program it, but it is limited. But anti-fuse, we could not able to reprogram it. Okay. It uses the non-standard CMOS technology. So because of that, we could not able to achieve the low power consumption, high speed, low area. That could not be achieved because it uses the non-standard CMOS technology. With this, I'm completing this programming technology topic. Next class, we will start the commercially available FPGAs. Thank you.